So I'd like to thank Nikki and Terry for helping schedule this seminar today, Laminate the Basics. And I would like to introduce our presenters. So I'm Grayson Braun. I'm the National A&D Manager for ABET Laminate. Presenting our first two sections, we have Kiva Rivera, who is the New York rep. We have for our middle sections, that would be 3 and 4, we have Robin Riggs, who is our A&D rep for Ontario and the Maritimes. And then our final two sections, we have Kat Grassam joining us from British Columbia. She also covers Alberta, Manitoba, and Saskatchewan. So moving right into this, this is an AIA accredited seminar. Today, we are probably more concerned with IDCEC. So we are also registered with IDCEC for continuing education credits. And I'm going to turn things over to Kiva Rivera to run through our learning objectives and begin the first two sections.
Thank you, Grayson. So today we're going to be talking about the history of HPL. We're also going to understand the process of laminate manufacturing. We're going to review the logistics of working with mill workers to ensure your design intent is honored and the appropriate shipping and handling of our material. We're going to also overview panel fabrication and troubleshoot some various items that can happen during a millwork manufacturing, and also review some projects that have successfully utilized HPL. So let's get started with the history of HPL. Although there are many products that are commonly called laminate, this presentation will only address the product category known as high pressure laminate, which is a combination of papers impregnated by melamine and phenolic resins, which are then baked under high pressure. Other materials on the market include direct pressure laminate, DPL, which is similar in composition to HPL, but is created under low pressure, resulting in a product with lower impact, moisture, and wear resistance than HPL. There's also TFL, which is a melamine saturated paper that is thermally fused directly to a substrate. Because it lacks multiple layers of craft paper, TFL is not as impact resistant as HPL and not suitable for horizontal applications. There are two different types of plastic. There are thermoplastics, which can be repeatedly softened by heating and hardened by cooling, for example, candle wax. And there are thermosetting plastics, which harden permanently after being heated. Since thermosetting plastics don't melt, it is often used to make products that are heat resistant. Thermosetting resins, such as melamine and phenolic, form the matrix for high pressure laminate. What is phenolic? Leo Hendrik Baekeland, a Belgian chemist, invented phenolics in 1913. The material he created is known as bakelite. It was used to create products such as umbrella handles, pipe stems, jewelry, and mahjong tiles. However, cured phenolic resin also provides the product rigidity necessary to maintain structural integrity and dimensional stability even under severe conditions. For this reason, phenolic resins are also specified for demanding applications such as foundry products. The resin known as melamine is made from urea, which is a readily available raw material produced from ammonia and carbon dioxide. It was perfected by American Cyanamid in 1938. Many people associate plastic laminate with mid-century furniture manufacturing. However, decorative laminate dates back to the late 1930s when melamine became available. Due to the outbreak of World War II, its uses were restricted to military applications. After the end of the war, production methods requiring melamine were returned to the realm of civilian use. Laminate began to be used as an electrical insulator in refrigerators and washing machines by Westinghouse micarta. A group of engineers thought that the material could be used for decorative applications. They left Westinghouse micarta and formed a company called formerly micarta. Westinghouse micarta sued the engineers for the use of the word micarta, but the judge threw the lawsuit out of the court, stating that he didn't really believe formerly micarta would sell enough material to be a threat. Today, formerly micarta is known as Formica. Moving on to our second section, let's review how high-pressure laminate is made. This is a simplified overview of the HPL manufacturing process. Resins are delivered to the factory. The paper is impregnated with these resins. These resin-impregnated sheets of paper are then layered together. They are then compressed and baked, more specifically and in photos. The papers used are backer sheets and untreated decorative paper. The backer material is craft paper, which is purchased in 1-ton rolls. It is similar to the brown paper bag in grocery stores. The decorative paper can be colored paper or printed paper. In either case, the rolls of paper are loaded into an unwind stand. The craft paper is unwound into a bath of phenolic resin, and the decorative paper is unwound into a bath of melamine resin. After the paper is treated and cured, it is then cut to length. The material is then stacked together. A surface plate which imprints texture is applied to the stack of paper. The stack of paper and plate are then loaded into a press, which compresses the material at over 1000 psi and bakes it at 325 degrees for 90 minutes. When the process is complete, you have a sheet of HPL. HPL can be used for both vertical and horizontal applications. It is resistant to minor scratching, impact, radiant heat, wears, and stains. It is a lower cost alternative to solid wood, stainless steel, solid surfacing, and stone. Even when fabrication costs are factored in, HPL uses fewer budget dollars on a project than other surfacing materials.
And now I'd like to introduce Robin Riggs, who is going to cover our next two sections.
Thank you. Now we're going to meet the mill workers. So you, the designers, have worked hard to create a space that is both pleasing and harmonious. Your client loves it, the GC has been selected, and now the bid-winning mill worker is on the job. So now we're going to meet the mill worker who has been awarded the project. There are many types of mill workers. However, for the sake of this presentation, we are going to focus on two. And this is a little bit tongue-in-cheek. In a perfect world, there is Aiden, then there is Hank. But before either mill worker can produce your finished millwork, they need to buy the materials that you have specified. When Aiden is awarded your project, he picks up the phone and calls for pricing. He is asked questions about the scope of work and the timing of the project, which he readily answers. He is provided with pricing. He responds, voices any concerns he might have, and once those have been addressed, he places an order for the material you have specified. If Hank is awarded your project, he waits until 2 weeks before the millwork is due to be installed before he picks up the phone and calls the manufacturer for pricing. He is asked for project information, which he refuses to provide. He doesn't bother to provide a quantity or mention that he has a tight timeline. General pricing is offered, and he is told that if he can provide project information, a discount structure can be applied. Suddenly, as if Hank is a magician, he offers the project information. So discounted pricing is offered, and he is assured that the material is available in as little as 3 days. He says that he will send a purchase order. But since Hank is not Aiden, that purchase order is never received, and with time ticking away, everyone waits. Follow up with Hank happens the next day, and if he takes the call at all, he says that he has no additional information. And he might not be taking the call because he is too busy calling the GC to tell him that the laminate that you specified is not in stock or costs 4 times more than another product. Usually this is where he tries to substitute a piece of white HPL he has left over from another project for the burnt orange color you painstakingly selected. So this process is repeated for a few days, sometimes weeks, and the A&D rep is asked to contact the specifier. Usually this produces some reaction, but we still have to stay on Hank, and if we are all lucky, he places the order for the material you have specified. In either case, whether it's Aiden or Hank, once the order is received, it can be shipped. Smaller orders are rolled, boxed, and shipped via UPS or FedEx. Up to 5 sheets of HPL can fit in a standard shipping box. Larger orders of 30 sheets or more are shipped flat in a crate. Once the HPL is received, the mill worker unpacks it and lays it flat in a climate-controlled area for 48 hours with the top sheet face down and a call board, which is simply a flat board, on top for protection. It's worth noting that all HPL should be stored horizontally. It is how manufacturers store laminate, and it is how the mill worker needs to store the laminate before it can be fabricated. Distributors provide more than HPL to the trade, which means that they have less space to store laminate, and as such, they store laminate in vertical bins. This requires that the laminate be bent for storage. If it's stored bent for a long period of time, it becomes harder for the mill worker to flatten and could lead to delamination from the substrate in a finished piece of millwork. The reason laminate needs to be stored flat for 48 hours is because it needs to acclimate to the environment where it is going to be worked. HPL and the substrates it will be applied to are paper products, which will react to humidity. When humid, laminate will expand. When dry, it will contract. The acclimation process lets the millworker know that the laminate and substrate are not reacting in opposite and drastic ways. Improper acclimatization can lead to glue failure, expansion and contraction, cracking and warping. These are all things we'll talk about in greater detail when we get into troubleshooting. Now that the HPL has been received and is appropriately acclimated, it can be fabricated. There are 4 components of a panel. They are the substrate, preferably MDF or particle board as recommended by the Architectural Woodworking Institute, the AWI, the adhesive, the laminate, and sometimes edge banding. AWI standards for the correct fabrication of HPL require that the substrate be either MDF or particle board. So what's the difference? Both are waste wood products, which provide a suitable face for bonding because they're engineered for flatness and stability, which supply the rigidity required to support HPL. Their dimensional movement is similar to that of laminate, which provides the perfect substrate for HPL. Particle board is manufactured from wood chips and sawmill shavings. It is low cost and lightweight, but it is also susceptible to expansion from moisture absorption. MDF is made from wood fibers as opposed to wood chips, and while it is more expensive and definitely heavier than particle board, it is durable, easier to mill, and better suited for projects with complex shapes. MDF and particle board expand and contract at a percentage that is greater than laminate. Plywood's rate of expansion and contraction is even greater, which is why AWI recommends using MDF or particle board instead of plywood for laminate fabrication. Despite this, plywood is still used for fabrication of laminate-faced millwork. Plywood holds screws better, it's stronger, it weighs less than MDF or particle board, it has better water resistance, and it's the least expensive option. However, its dimensional stability is different from that of HPL, which poses a greater risk of warping, cracking, or delaminating. The next component of panel fabrication is the adhesive. Contact adhesive is easy to apply as it's a spray application. It can be solvent-based or water-based. In either case, the solvent or water needs to evaporate from the surface before a satisfactory bond can be made. Solvent-based adhesive dries more quickly, but it is more toxic than water-based adhesive. PVA polyvinyl acetate adhesive is basically wood glue. It provides a rigid bond with less chances of stress cracking, but it also requires a 24-hour cure time and the use of a hot or cold press to clamp it while it cures. You also want to make sure that the adhesive, whether it's contact or PVA, has also had a chance to acclimate to the environment where it will be worked. Now that everyone knows about substrates and adhesives, we can move on to edge banding. And we'll look at the 2 most common types, which are roll edge and self edge. Roll edge is generally PVC or ABS, and of these two, ABS is considered the green edge banding option. Self edge is when HPL is cut to width and used on the panel edge. There are also wood edge bandings and metal edge bandings, depending what your design intent is. As applies to your project, let's work it out. For smaller projects, for example, a bathroom vanity or a single pantry in an office, your project will likely be used using contact adhesive and self-edge edge banding. For larger projects, such as desktops for 600 workstations made by one of the large commercial office furniture providers, your project will likely be built using PVA glue and edge banding. Generally, in large-scale production, a glue spreader, such as the one depicted in this image, is used to apply PVA glue to the substrate. Once the laminate is adhered to the substrate, the panels are put in a cold press, like this one, for approximately 24 hours until the glue dries. Now we're going to look at a video depicting a large-scale panel layout process, resulting in a balanced panel. So you can see the stack of the MDF. The MDF is going through the glue spreader. The glue is spread on both sides. So he gets it all lined up. It's brought over to a piece of laminate that is face down. So it sits on top of the laminate being put on one side. And then he's bringing over the other sheet of laminate to balance the panel. And he lines it up, places the next sheet face down to receive the next piece of the substrate, the MDF, which is ready waiting for him. Neatens the stack, brings over the MDF. And brings over the other sheet on top. So you can see he's got the laminate on each side of the substrate, and that means that the panel is going to be balanced. It's really important that the laminate on each side is the same thickness, otherwise they're going to pull at different rates, and you can result in a warped panel, which can delaminate or have stress cracks. So he's got the whole stack there ready to go into the press. He lines it up. And sets the machine, and that will set for the 24-hour period. And when it comes out, it's ready to be sent to the fabricator. Or if they're doing the layup in-house, then they can fabricate the panels right there. In a smaller shop, it's more likely that the mill worker is using contact adhesive. This is the spray application of contact adhesive. It's important that the applicator overspray the edges of the sheet as well as the substrate on both sides so that the laminate adheres properly. You can see he's putting a good amount on there, very even, very consistent, and he's going to put this on, again, both sheets of laminate and both sides of that substrate. One of the reasons that mill workers like to use contact adhesive is because it offers greater flexibility during the fabrication process. Once the adhesive has been applied, there is a period where the solvent flashes off. This time period is known as the open time. During this time, you can touch the panel and not get stuck. Mill workers use this open time to properly position laminate onto the substrate. Dowels are placed on the substrate during open time. They are used to separate the laminate from the substrate until the material is properly positioned. So here he's going to place the sheet of laminate over top of the dowels. He's got his substrate ready to go under there. And he systematically starts removing the dowels once he's got everything lined up. When he's satisfied with the position of the sheet and the open time is coming to a close, the dowels are removed. He uses a tool called a J-roller, which assures the contact between the laminate and the substrate is made and adhesion is complete. A J-roller gives 40 pounds per square inch, giving the best bond. And the way he holds it distributes even pressure, removing all of the bubbles. On a warranty claim where only the edges are lifting, you might ask if sufficient contact adhesive was applied to the edges. And here, a laminate trimmer is being used to cut the excess flashing, just to perfect those edges. Finally, the edge of the panel is hand filed to blunt the 90-degree edge. In a large millwork operation, this process would be completed using a CNC machine. If you don't blunt the edge, it can result in hairline cracks, which can spread across the sheet and lead to a stress fracture.
And for our last two sections, I'd like to introduce Kat Grassam.
Hi, so I'm going to talk about troubleshooting. So we've reviewed all of the different ways we can get to our finished project, and now it's been installed. And there's a few things that could go wrong. In this section, we're going to troubleshoot some of the common problems that arise from various things affecting HPL, specification, fabrication, and appropriate areas of use. I will say that in my 30+ years of either receiving CEUs or presenting CEUs about laminate, there has never been a section as such as this one. This one helps you to be prepared to do a walkthrough where there is an issue on site with laminate. I can tell you that laminate is almost never, ever to blame. This section is going to give you knowledge and insight to speak confidently to the GC and the fabricator as to what has occurred. Knowledge is king. And sometimes when you're on site, you are made to feel like you do not know what you're talking about. So hopefully this is going to give you a little ammunition. So the first one is telegraphing, orange peeling, rippling, oil canning. It can be caused by a few things, including uneven distribution of glue. So when we saw that guy spraying the contact adhesive on, if he has it too thick in some areas, that can come through and show on the other side. Using a low grade plywood, so not using an A grade plywood, will cause this to happen. It can also be caused by excessive pressure in the drying time, meaning if the pressure is too great or too long, any imperfections like air pockets that are in the middle of an MDF panel can be squeezed to the surface and show through as bubbles or ripples, and it especially is evident in a gloss. And then if we look at cupping, this occurs when a panel is inadequately balanced. Robin talked about how you have to have material on either side of the substrate that is the same thickness, and that will prevent dimensional movement and limit it so that it's expanding and contracting on the face and on the back at the same ratio. If it's not, then it can actually peel away from the substrate, or it can result in a crack. If we look at warping, it's different from cupping, and it's that the deformity occurs when the moisture content of different parts of a piece of wood change unevenly. So, for example, the mill worker acclimatizes the laminate, but he stores his substrate in a lean-to outside and it's -40, and he brought that in and didn't acclimatize the substrate. So the laminate gets laid up on a moist piece of wood. So as that dries out in the center, it causes something that was flat. I've seen 3/4 inch MDF cup up to 4 inches or warp up to 4 inches because of not acclimatizing the material. If we look at the next screen, this is delamination. And this is example of a glue failure which has led to the laminate to pull away from the substrate. In this image, it's not the laminate that has failed, it's the adhesive. So it's either the substrate or the adhesive, which is usually the problem. In this condition, it's caused often by an inadequate amount of adhesive on the panel, particularly at the edge. It can also be caused by too much heat in the press if it was left there for too long. It can be caused by lack of pressure because it needs to be, as Robin said, 40 psi of pressure, not a 2x4 and a hammer tapped on a piece of wood, or not a pallet of empty boxes stored on top. It could be that they also left it to flash too long, or to not long enough. And if the contact adhesive is applied originally with heat, interestingly enough, if there's enough adhesive there, you can reheat that adhesive and apply 40 psi and put that piece of laminate back down on the edge. You can also inject contact adhesive. Sometimes when people put a hot pot on a laminate countertop and the heat, there's a bubble that forms. It's because the heat has reactivated the adhesive, and simply putting a damp cloth down with an iron for heat and reactivating that adhesive and then applying 40 psi will relaminate your countertop. It's called vulcanization. I don't know why it's very Star Trek-y sounding, but that's what that is. If we look at the next screen, there's a few different examples of cracking here. They can be from acclimatization. We can have cupping happening here. In my opinion, these first two here, those are stress fractures because the corners, they're inside corners and they haven't been radiused properly. If we look at the one on the right, that is in a frame. It could be that they didn't file, as Robin talked about, the edges properly. And so one of those little tiny hairline cracks was allowed to go. And if there was any torquing on that sign, it would just snap. And then if we look at the next one, as previously mentioned, to avoid cracking of all the material used in fabrication, it needs to be acclimatized in a controlled environment for a full 48 hours. Again, to me, these both look like additional pressure was placed on the laminate on the inside corner. If you remove that cover on the duplex outlet, there's probably 90 degrees under there. The image that is on the right, it could be that it's laminate that's on a wood substrate going onto drywall, and drywall is not a suitable substrate. And again, at that inside corner, there's too much tensile strength and it's caused a crack. So what is very, very important to know is that 90-degree inside corners should never, ever be used in laminate. It has to have, and all woodworking associations will tell you that there has to be a radius of 1/8 of an inch or larger on all inside corners. Yes, even that inside corner on an L countertop should have 1/8 of an inch radius. All inside cutouts should be routed and filed to ensure smooth edges. Not filing a cut leaves tiny hairline cracks in the laminate that can potentially run across the sheet, especially if the sheets were not acclimatized, not enough pressure, or insufficient glue on parts of the sheet. Radiusing the corner distributes an even distribution of pressure, and not all the pressure is focused on that one point as it would be in a 90-degree corner. Unfortunately, sometimes mill workers do not control the environment because sometimes it's an electrician will come on the site and do the cutout for the duplex outlets. The next slide will show us where you properly radius the corners, how you don't have those stress fractures. In the next screen, this is very interesting. This is the same laminate. It is exactly the same laminate. What's important to know that even in solid colors with laminate, it is directional. Like fabric, there is a head and there is a toe. And that direction is determined by the plate that is used in the top of the stack way back when Kiva was talking about when it went into the press, and that's what gives it the finish, that plate. That's what determines what's the head and the toe. This means that during fabrication and during installation, if one of the sheets of laminate are inverted, they will appear to have different colors due to the difference in the light reflectivity. This is a great example here on an install. It can also occur if the fabricator uses an offcut that may be a shoulder-to-shoulder piece, and he puts it together with a head and a toe, it will look like a different color. We get lots of inquiries about the durability of a gloss finish versus a matte finish versus a textured finish. The truth is that they're all equally durable. The real difference between the two is the light reflectivity. In this particular example, both pieces are laminate, are in a gloss finish, and both pieces of laminate have been scratched equally using a box cutter. The scratches on the darker color are more visible than the scratches made on the white. This is because the decorative paper that gives you the color, the pattern, is impregnated with a melamine resin. And when the melamine resin is scratched, it fractures and it turns white. So therefore, it's obviously less noticeable on the white HPL because it matches the decor. If you have a texture and you put a scratch on it, think of it as peaks and valleys. So you only seem to scratch the peaks and not the valleys, so it doesn't read as a solid line. And the previous NEMA standards, which is now called ISO, testing method for testing scratching on a laminate is they place the laminate on a 30-degree angle. There is a pointed metal pendulum that is swung across it, and the findings, gloss finish shows more than textured finishes or matte, and light colors show less than dark colors. That's the results from ISO testing. If we go to the next thing, so it is recommended, regardless of the finish, think about the colors and the finish when you're looking at durability. So for a horizontal surface that you're writing on, you may not want to be using a textured surface, but you may want to consider a lighter color and using darker colors elsewhere. This next slide, because it is formed under high pressure, HPL is non-porous, which makes it both difficult to stain and very easy to clean. To prove our point, this image shows a stained piece of a white HPL with permanent ink. It is cleaned with the Mr. Magic Clean Eraser. The dot on the right side is left only to show that it's the same piece of laminate and that we didn't actually switch it. Color through laminate. We are all very aware that you guys find that brown line edge to be fairly offensive. And I will tell you that your brown line is only as good as your mill worker. Some are better at hiding it than others. We are also aware that color through laminate is often viewed as the best thing, as the one thing standing between your design intent and the dreaded brown line. The thing about color through laminate, when it's fabricated properly, it does exactly what you want it to do. It doesn't show that line, but you have to consider that it is comprised of all decorative paper and there's very little phenolic resin in it. So what does that mean? It makes it much more brittle. It's much more expensive, and it's very rigid and difficult to fabricate. And it's more susceptible to dimensional change, which means that they have to get the PSIs right when they're putting it on. They have to make sure they have adequate glue coverage. And most importantly, they have to radius, because there's so much tensile strength in full color through laminate, that inside corner has to be 1/4 of an inch or more to evenly distribute pressure on that corner so it doesn't crack. There's also a couple of other things. When you do full color through, you cannot use plywood as a substrate, and you have to use PVA glue. And it has to be balanced equally. Typically, full through colors are a little bit thicker than regular laminate. So therefore, your backer panel has to be the same thickness, or you will get cupping. And then our last section is we're going to review different types of projects where HPL has successfully been utilized. Oh, yeah. So the first one here, this is a restaurant. HPL is an excellent choice for use in restaurants. You need to go one more slide, Grayson. There we go. High impact resistance and cleanability, non-porous like real wood, makes wood grain laminates awesome to use. No endangered species were killed in the making of this realistic, warm, and durable laminate. It's perfect for restaurants. This is a servery. It's great for that because it is food safe because of its non-porous nature. And the next one is other food service areas. The next one is a coffee shop. It's a regional chain in Massachusetts called Mary Lou. Trends differ from continent to continent. North American lines tend to have less solids than European lines, where in Europe they embrace the bold, bright solids. We see it frequently used in showrooms, as the Stark showroom in Boston. Healthcare facilities use a vast amount of HPL. This is Tufts Gross Anatomy Lab in Boston. Residential kitchens remain a popular venue for HPL. This is a private residence in New York. The next one is a condo. And it's often laminate is used as a standard for multi-residential units. This is a great place to mention the difference between the TFL that Kiva talked about in the beginning, where that's your decorative paper is adhered directly to the substrate. And then with laminate, it's comprised of decorative paper, layers of craft paper, and it's pressed and baked to create a strong sheet that is then adhered to a substrate. This is what gives laminate impact resistance that TFL does not have. When ISO does testing for impact resistance, they use a 1-inch metal ball. This metal ball bearing is dropped from various heights until indentation occurs in the substrate is damaged. With TFL, 15 inches is typically the height. With HPL, it ranges from 30 to 50 depending on the thickness of the actual laminate sheet, meaning that high wear areas take lots of abuse should use laminate. Door faces, drawer fronts, and horizontal surfaces, end gables, and maybe the fronts of bars in residential kitchens are better suited for TFL. In bathroom vanities, this image shows a really good use of PVC edge banding on the side of that drawer. HPL is still a very popular choice for commercial interiors. This is a nice use of fingerprint resistant HPL in a high-tech campus in Eindhoven in the Netherlands. And then if we look at the next one, it is very great to use in hospitality applications. One, it's durable, it's easy to clean. Think about using HPL for interior suite entry doors, as they did in this application here. It can withstand more impact than a wood door can. Think about moving day in condos and rental units and all that all those things bumping up against the door. Think of suitcases and other travel items in a hotel. The other thing is that a laminate wood grain will not patina, nor will it oxidize, and they will remain consistent in coloration, unlike stained wood, which means if a door needs to be added or replaced in a long corridor, it's going to be far less noticeable than what would happen if it was a wood door. Laminate is also great for lockers. This particular locker room is in an Equinox gym in Southern California. Higher end gym, obviously. These are toilet cubicles that are located in Rotherham United Football Stadium in the UK. The nice thing about laminate is it can be manufactured to full height for greater privacy, accommodating all genders. Another application for bathrooms. And it's always fun to learn something new that most of us didn't know before. Some manufacturers can produce laminate and high gloss that is also suitable for dry erase marker boards, which makes them ideal not only for offices, but for healthcare applications. I have seen architectural offices that they've done their boardroom table in gloss so they can spread out their drawings and put notes actually right on the table. This is an office in Southern California. I just want you to remember that not all laminates are created equally. Ghosting may appear with some brands if you use a gloss as dry erase. And so be sure to ask your reps about it. And FYI, hand sanitizer and a soft cloth is the best thing for cleaning dry erase marker board. And at the moment, we all have tons of hand sanitizer around. If we go to the next slide, another fun fact about HPL is that it can be made in various thicknesses. In this example, this is color through compact grade in 12 millimeter or ½ inch. It's also known as solid core phenolic or compact grade. In Europe, the trend right now is for a thin countertop line. So they're not doing a built-up edge. And why is compact grade so good? You can do an undermount sink. It can cantilever 15 inches without a support. It can span between 36 and 48 inches, so gable to gable. Drawer faces and door faces can be finished either top or bottom with a knife edge, and this can eliminate any hardware on the front. There is no edge banding, so you're not going to have delamination. And you can waterfall it like they did in that example. It's offered in a thickness with the color through up to 14 millimeters, so it can be used for boxes as well. And as door faces. And when you can also use threaded nylon or metal inserts and screw a table base right to the bottom of it and finish the edge. It's also an alternative for laminate on lockers. You can use, oh, I'm a little bit ahead, Grayson, on the next one. So this is lockers that are done in compact grade, so thick grade laminate. And then we have, this is toilet partitions done in solid phenolic. This is the Dale Youth Boxing Club in London. And then finally, when you add a UV protection and you use 8 mil or 10 mil thick HPL panels, they can be used exterior as a rain screen facade system. This is a residential project in Brooklyn, New York. And then another one, the last one, this is also an exterior grade phenolic project in New Platts in upstate New York. Ask your rep if you are interested in learning about exterior rain grade or getting a CEU. Thanks.
So thank you, everybody, for joining us. If anybody wants to stick around and has questions, I guess now is probably a good time to ask if anybody has any. Unmute your microphone, sing out. Okay, so hearing, oh, go ahead, sorry. Okay, so I thought we had somebody with a question, but I guess not. So hearing no questions for anybody who wants to stick around, just very quickly. Obviously, the four of us represent ABET Laminati. We manufacture high pressure laminates. We do have a North American stock collection. And within that collection, we have our Polaris fingerprint resistant laminates. They are available in 10 neutral tones, and they are acrylic impregnated laminates, so they are fingerprint resistant. It also offers a certain degree of antibacterial property to the material. We have a vast array of colors and textures. There are something over 200 different colors and various textures. We have over 100 wood grain options, and wood grain laminates have come quite a long way in the last couple of years, so you should check that out. We offer some stones, a series of magnetic dry erase and chalkboard marker laminates, a couple of metal options as well. We offer an antibacterial material, which is called LamiShield. It actually employs BioCoat technology that kills bacteria, so it's perfect for healthcare applications. And all of this can be seen in our ABET Laminati chipbook, which is available by contacting one of your ABET Laminati reps. So again, thank you so much for joining us today.
have been scratched equally using a box cutter. The scratches on the darker color are more visible than the scratches made on the white. This is because the decorative paper that gives you the color, the pattern, is impregnated with a melamine resin. And when the melamine resin is scratched, it fractures and it turns white. So therefore, it's obviously less noticeable on the white HPL because it matches the decor. If you have a texture and you put a scratch on it, think of it as peaks and valleys. So you only seem to scratch the peaks and not the valleys, so it doesn't read as a solid line. And the previous NEMA standards, which is now called ISO, testing method for testing scratching on a laminate is they place the laminate on a 30-degree angle. There is a pointed metal pendulum that is swung across it, and the findings: gloss finish shows more than textured finishes or matte, and light colors show less than dark colors. That's the results from ISO testing. If we go to the next thing, so it is recommended, regardless of the finish, think about the colors and the finish when you're looking at durability. So for a horizontal surface that you're writing on, you may not want to be using a textured surface, but you may want to consider a lighter color and using darker colors elsewhere. This next slide, because it is formed under high pressure, HPL is non-porous, which makes it both difficult to stain and very easy to clean. To prove our point, this image shows a stained piece of a white HPL with permanent ink. It is cleaned with the Mr. Magic Clean Eraser. The dot on the right side is left only to show that it's the same piece of laminate and that we didn't actually switch it. Color through laminate. We are all very aware that you guys find that brown lime edge to be fairly offensive. And I will tell you that your brown line is only as good as your mill worker. Some are better at hiding it than others. We are also aware that color through laminate is often viewed as the best thing, as the one thing standing between your design intent and the dreaded brown line. The thing about color through laminate, when it's fabricated properly, it does exactly what you want it to do. It doesn't show that line, but you have to consider that it is comprised of all decorative paper and there's very little phenolic resin in it. So what does that mean? It makes it much more brittle. It's much more expensive, and it's very rigid and difficult to fabricate. And it's more susceptible to dimensional change, which means that they have to get the PSIs right when they're putting it on. They have to make sure they have adequate glue coverage. And most importantly, they have to radius, because there's so much tensile strength in full color through laminate, that inside corner has to be 1/4 of an inch or more to evenly distribute pressure on that corner so it doesn't crack. There's also a couple of other things. When you do full color through, you cannot use plywood as a substrate, and you have to use PVA glue. And it has to be balanced equally. Typically, full through colors are a little bit thicker than regular laminate, so therefore your backer panel has to be the same thickness, or you will get cupping. And then our last section is we're going to review different types of projects where HPL has successfully been utilized. Oh, yeah. So the first one here, this is a restaurant. HPL is an excellent choice for use in restaurants. We need to go one more slide, Grayson. There we go. High impact resistance and cleanability, non-porous like real wood, makes wood grain laminates awesome to use. No endangered species were killed in the making of this realistic, warm, and durable laminate. It's perfect for restaurants. This is a servery. It's great for that because it is food safe because of its non-porous nature. And the next one is other food service areas. The next one is a coffee shop. It's a regional chain in Massachusetts called Mary Lou. Trends differ from continent to continent. North American lines tend to have less solids than European lines. where in Europe they embrace the bold, bright solids. We see it frequently used in showrooms, as the Stark showroom in Boston. Healthcare facilities use a vast amount of HPL. This is Tufts Gross Anatomy Lab in Boston. Residential kitchens remain a popular venue for HPL. This is a private residence in New York. The next one is a condo. And it's often laminate is used as a standard for multi-residential units. This is a great place to mention the difference between the TFL that Kiva talked about in the beginning, where that's your decorative paper is adhered directly to the substrate. And then with laminate, it's comprised of decorative paper, layers of craft paper, and it's pressed and baked to create a strong sheet that is then adhered to a substrate. This is what gives laminate impact resistance that TFL does not have. When ISO does testing for impact resistance, they use a 1-inch metal ball. This metal ball bearing is dropped from various heights until indentation occurs in the substrate is damaged. With TFL, 15 inches is typically the height. With HPL, it ranges from 30 to 50 depending on the thickness of the actual laminate sheet, meaning that high wear areas take lots of abuse should use laminate. Door faces, drawer fronts, and horizontal surfaces, end gables, and maybe the fronts of bars in residential kitchens are better suited for TFL. In bathroom vanities, this image shows a really good use of PVC edge banding on this side of that drawer. HPL is still a very popular choice for commercial interiors. This is a nice use of fingerprint resistant HPL in a high-tech campus in Eindhoven in the Netherlands. And then if we look at the next one, it is very great to use in hospitality applications. One, it's durable, it's easy to clean. Think about using HPL for interior suite entry doors, as they did in this application here. It can withstand more impact than a wood door can. Think about moving day in condos and rental units and all those things bumping up against the door. Think of suitcases and other travel items in a hotel. The other thing is that a laminate wood grain will not patina, nor will it oxidize, and they will remain consistent in coloration, unlike stained wood, which means if a door needs to be added or replaced in a long corridor, it's going to be far less noticeable than what would happen if it was a wood door. Laminate is also great for lockers. This particular locker room is in an Equinox gym in Southern California. Higher end gym, obviously. These are toilet cubicles that are located in Rotherham United Football Stadium in the UK. The nice thing about laminate is it can be manufactured to full height for greater privacy, accommodating all genders. Another application for bathrooms. And it's always fun to learn something new that most of us didn't know before. Some manufacturers can produce laminate and high gloss that is also suitable for dry erase marker boards, which makes them ideal not only for offices, but for healthcare applications. I have seen architectural offices that they've done their boardroom table in gloss so they can spread out their drawings and put notes actually right on the table. This is an office in Southern California. I just want you to remember that not all laminates are created equally. Ghosting may appear with some brands if you use a gloss as dry erase. And so be sure to ask your reps about it. And FYI, hand sanitizer and a soft cloth is the best thing for cleaning dry erase marker board. And at the moment, we all have tons of hand sanitizer around. If we go to the next slide, another fun fact about HPL is that it can be made in various thicknesses. In this example, this is color through compact grade in 12 millimeter or ½ inch. It's also known as solid core phenolic or compact grade. In Europe, the trend right now is for a thin countertop line. So they're not doing a built-up edge. And why is compact grade so good You can do an undermount sink. It can cantilever 15 inches without a support. It can span between 36 and 48 inches, so gable to gable. Drawer faces and door faces can be finished either top or bottom with a knife edge, and this can eliminate any hardware on the front. There is no edge banding, so you're not going to have delamination. And you can waterfall it like they did in that example. It's offered in a thickness with the color through up to 14 millimeters, so it can be used for boxes as well. And as door faces. And when you can also use threaded nylon or metal inserts and screw a table base right to the bottom of it and finish the edge. It's also an alternative for laminate on lockers. You can use, oh, I'm a little bit ahead, Grayson, on the next one. So this is lockers that are done in compact grade, so thick grade laminate. And then we have, this is toilet partitions done in solid phenolic. This is the Dale Youth Boxing Club in London. And then finally, when you add a UV protection and you use 8 mil or 10 mil thick HPL panels, they can be used exterior as a rain screen facade system. This is a residential project in Brooklyn, New York. And then another one, the last one, this is also an exterior grade phenolic project in New Platts in upstate New York. Ask your rep if you are interested in learning about exterior rain grade or getting a CEU. Thanks.
So thank you, everybody, for joining us. If anybody wants to stick around and has questions, I guess now is probably a good time to ask if anybody has any. Unmute your microphone, sing out. Okay, so hearing, oh, go ahead, sorry. Okay, so I thought we had somebody with a question, but I guess not. So hearing no questions for anybody who wants to stick around, just very quickly. Obviously, the four of us represent ABET Laminati. We manufacture high pressure laminates. We do have a North American stock collection. And within that collection, we have our Polaris fingerprint resistant laminates. They are available in 10 neutral tones, and they are acrylic impregnated laminate, so they are fingerprint resistant. It also offers a certain degree of antibacterial property to the material. We have a vast array of colors and textures. There are something over 200 different colors and various textures. We have over 100 wood grain options, and wood grain laminates have come quite a long way in the last couple of years, so you should check that out. We offer some stones, a series of magnetic dry erase and chalkboard marker laminates, a couple of metal options as well. We offer an antibacterial material, which is called LamiShield. It actually employs BioCoat technology that kills bacteria, so it's perfect for healthcare applications. And all of this can be seen in our ABET Laminati chipbook, which is available by contacting one of your ABET Laminati reps. So again, thank you so much for joining us today.
Grayson?
And, yes.
Before you go, we did have a question that was in the chat box. It says, some of the projects I work on are state funded and they require plywood substrates for countertops. What other specification besides grade A plywood differ from a spec for MDF or particle board?
Okay, so if I understand this correct, I mean, honestly, the only substrate we would say is acceptable would be that grade A plywood, marine grade plywood for that type of an application.
Okay, and that looks like the last question in our queue.
Okay.
So, all right. There was some, I just want to thank everyone for coming. And if you'd like to unmute your microphone or your video and just have a quick chat, feel free to join us. And we look forward to hearing visiting with everybody. Okay.
That was really great. Thank you. I always like seeing the troubleshooting parts.
Yeah, it lets you know. I find when I would go on job sites and there was an issue, I always felt like I was being talked down to, that I didn't know what I was talking about as a designer. And so the more education you have about things, the better you feel, the more comfortable you feel on site when there's an issue, in my opinion.
Yeah, I would agree with you on that. I used to work for a paint. I used to sell paint. And very often the problem was in the substrate, not the actual paint on top. Like you just can't cover up the problem and expect it to go away.
Exactly.
Well, thank you so much for your time. I'm gonna log off here. Thank you.
Hi, Peter. This is Peter Yip, who just joined us on screen.
Hi.
He's president of our
Hi.
chapter. Thank you for attending today.
Thank you.
Well, I'm going to stop the actual broadcast of this since people don't seem to be coming on, but I wanted to let you know there was a glitch in the beginning of it for the recording purposes. But if you want, we can pull this off and then you can come back in and I can re-record the beginning and then splice them together for you.
Okay.
So
I mean,
if you guys have time to read through the beginning at this point.
Sure. The other thing too, Kiva, tomorrow, the seminar that we're doing, is that Laminate the Basics again?
No.
It's not. Okay. All right. So then we'll have to redo the beginning. Which sections do you need us to redo?
Well, it kept glitching in and out. So if I can get your introduction with the disclaimers and Kiva's section, I should be able to match them up. If we get, and who came after Kiva? Robin. If we just go through yours, that way I know where those glitches are. I was trying to time them out on my sheet here to say where they were. But I will patch them all together and get you a video by tomorrow for your call.
Okay. Thank you.
Okay. Yeah. All right. So
just give me 1 second because I know my dog is going to bark in like 2 seconds. So.
Okay. Well, I'm going to end this for everybody. And thank you for coming, everyone. Peter, it was delightful to see you.
Peter, thank you for reaching out. That was just such
See you
a great
later.
Okay. Bye.
Peter.
Okay. Bye.
Bye, Peter.
Bye.
Okay. So from
All right. Yeah.
You need me here? The troubleshooting part, is that okay? Because I
troubleshooting part seemed to be okay. But I just want to make sure I get those first sections. I'm not even sure if the glitch was halfway through Kiva's or Robin's. I just noticed my light on my camera kept going on and off on the record, which has never happened before. So if we just keep recording, I'll splice this to the beginning of it and then you'll have one straight through video.
Okay, perfect.
Okay, so I'm going to count down from 5 and then Grayson, you can start. We're going to go in 5, 4, 3, 2, 1.